Hey team, today we are going to talk about odd-shaped polygons. It's been easy enough. You guys know formulas. There are squares, there are rectangles, there are all sorts of triangles that we know how to find the area of. Today, what we're going to do is we're going to take what we know about finding the areas of polygons, and we're going to utilize that to find the areas of polygons that we don't recognize. Now, this has a name. It's got 1, 2, 3, 4, 5, 6. Is that 1, 2, 3, 4, 5? No, 5. It's got 5 sides. So this is a pentagon, but it is certainly not a regular pentagon, and we certainly don't know a formula to find its area. But we do know the formula for some shapes like rectangles and squares and triangles that we can use to figure this out. So the first thing we want to do is take a look at this and the points that we have. And we're going to say, all right, well, I don't know how to find the whole thing. So maybe what I can do is somehow break it up. So the first thing that we can do is one thing we can consider is we can go ahead and break it into a shape that we do know by doing it outside figure there. And so what I've done is you've seen I have done a, let's see, that's 2 and 3. That makes 5. And that's 3 and 3. That's 6. So this is 5 by 6. So what we can do is I can label this and I can say, well, this is a rectangle that is 5 by 6. And since we know that the area of a rectangle, that's a rectangle, is equal to length times width, we know that that area is equal to 5 by 6, right? And we know it's equal to 30 units squared. Well, that's helpful, but it gives me this rectangle, but it certainly doesn't give me the purple part. But what it does allow me to do is figure out these 1, 2, 3 triangles. And if I figure out these 3 triangles, I can do, well, I can subtract them from the rectangle, and what the only thing left over would be our irregular figure here. So the first thing I see is that's 2, 3. I know that the base of this is 3, and I know that already that the entire height is 5. So that's got to be 15, but we know that area of a triangle is equal to the base times the height divided by 2. So 5 by 3 is 15, divided by 2, or half of that, is 7.5. Let's look at our second one here. That we know is going to be 2, 3. That's also 3. Well, we actually knew the whole thing was 6, so we should have been able to figure it out that way. 3. And we know that this height is 2 and 3. That's 3 also. So there's my 2, and one more makes 3, which means that the area is the base times the height is 3 times 3, which is 9, divided by 2 is 4.5. And then lastly, we have the big one up top, which we know across is 6 we've identified, and the height of that triangle is 2. We can see it right here is 2. Which means that the whole thing, actually, I'm going to erase that because I think it gets confusing the way I did that. I don't want to confuse the guys, so I'm going to erase that there. And what I'm going to simply highlight when I write it is that this part right here is, that there is 2 from here to here. Which means that this must be 6 by 2, which is 12, and half of that is 6. So if I take all of those, if I take these odd shapes here, I've got 4.5 and 7.5 is 12, and 12 and 6 is 18. So I know that the little triangle pieces, so my triangles equal 18 units squared. So I know that if I take my rectangle and I subtract out the triangles, I'm going to say triangles plural, I know that I would have 30 minus 18, which means that the area of our crazy figure equals 12 units squared. There you go. There's one way to do that. All right, that's part one of this. So you can take a look at that. You can come back and review this if you want. But guess what? I'm going to clear it all off because there's another way to go about this. Maybe instead of going around the whole thing and doing the outside, I'll turn this off. I'll come back to my original figure. One thing I can do is figure out that, well, I can find out, I can break the figure itself into three pieces. So there's my figure. All I've done is highlight three triangles that I know, and I can do each of those and then just simply add them together. And so let's take a look at what we know again. So once again, we're going to take them individually. I'm going to look at that orange and I'm going to look at it and say, well, that's 2, and the base here is 3, which was helpful because it gives us the base of the red one as well. And then I can look at this piece here, which is also for the red one, and that's also 3, which also helps us for the green one. The green one height, now be careful. The height is the distance from the base up to the tip, which means that even though this tip sticks out beyond the base, the height of this triangle is still on this extended part coming out. The height of this triangle is still only 3 units here. So let's go ahead and figure that. I'll change colors so it'll be easier for us to identify. I'll do it in green. So this green one here we know is 3 by 3, which is, again, we're back to area is equal to base times height divided by 2, which would be 3 by 3. This one here, 3 units here, and 3 units high is 9, which means that the area of this is 4.5. Here I have 3 by 3, which is 9, which means this is also 4.5. It's a different shape, but it's the same area. And here we have is 3 by 2, which is 6, and half of that is 3. So I go ahead and put those together. I get the area of triangle 1 is 4.5. Triangle 2 is 4.5. And then triangle 3 is only 3. I put them together, I get an area this time of my crazy thing is equal to 12 units squared. Oh my goodness, that's just what we get. We did it the other way. We did it completely opposite. We got the exact same answer. And so we can do it either way, whichever one either you're more comfortable with or makes more sense for you as you're doing them, you should do that. And I would guess that with certain figures, sometimes it's easier to go one way, sometimes it's easier to go another. All right, folks, on that note, that's everything. You go ahead, you got that video now. Let's go ahead and go to the formative assessment, and then we'll move on to today's activity. All right, good luck. Hope that helped.